Hi mathematicians, and welcome to the last vocabulary video of the unit. We are looking at the vocabulary words for lesson 10, and this is on rectangle proofs. So just like prior lessons, we are going to discuss some of the theorems that are needed. We're going to make sure we understand the foundations of it, and then in the actual lesson video, we can go more into depth on these vocabulary words. So up first, we want to make sure that we, once again, understand the difference between quadrilateral, parallelogram, and rectangle. And we're going to throw in that right angle, right, that's specific to rectangles. So remember that a quadrilateral is just simply a four-sided shape. We have an example of a four-sided shape right up here, right? Four sides, and then as we're becoming more specific, we have a parallelogram, and a parallelogram is a four-sided shape whose opposite sides are parallel. Now getting even more specific, we have a rectangle. Rectangles are parallelograms, but all four angles are right angles. So all four angles are 90 degrees. Remember, right angle means 90 degrees. Okay. Next, we want to make sure that we understand the parts of a parallelogram, which will also apply to a rectangle. So remember that a diagonal is a line that goes from one angle to the opposite angle in our quadrilateral. To bisect means to divide perfectly in half. So when we're in the parallelogram lesson, we discussed how the diagonals bisect each other. So that means that each one of these little halves are equal in length. Next, funny, we've got, remember that parallel means that our lines go on and on and on and on forever, and they remain the same distance apart, never to cross. And then lastly, remember that the word congruent means to be the exact same, equal in shape and size. So in this case, right, our segments that are bisected are congruent to each other. They are equal to each other. Okay. Up next, supplementary, transversal, and consecutive angles. These are things that we have used multiple times to prove different ideas regarding parallelograms, and we're going to use them again when we are talking about rectangles. So supplementary means that we add up to 180 degrees. Transversal is a line that cuts two other lines. So if we have these parallel lines right here, transversal will be the line, this diagonal that we are working with. We can treat it as a transversal. And consecutive angles are angles, two angles that are on the same side of the transversal. So interior, consecutive, interior, right? We would be working with this angle here and this angle, or consecutive, not that angle there. We'd be working with this angle here. Consecutive, same side of the transversal. Alrighty. Next, CPC/TC is never going away. We are using it because we are working with triangles to prove other things, right? CPC/TC, corresponding parts of congruent triangles are congruent. So if we have these corresponding angles, which are blue, or this corresponding side, which is tick mark 3, because my triangles are congruent, they are also congruent. So that means these angles are the exact same size and the exact same shape. If this one is 60 degrees, this one is also 60 degrees. If this is 10 centimeters, this one is also 10 centimeters. They are, in fact, congruent. Side congruence theorem. We are looking at the corresponding sides of our triangles, and we are confirming if they are congruent, all three of them, then we have congruent triangles. Our triangles are congruent if all of our sides are corresponding and congruent. Side angle side, we are looking at a side and then an angle and then another side, back to back to back to back, right? And if we have this included angle and our sides are also corresponding and all of them are congruent to each other, then that means that our triangles are congruent. So tick mark 1 is corresponding and congruent to tick mark 1 on our second triangle. So basically PQ is congruent to WX angle Q to angle X, and QS to XY. If these are congruent as they are corresponding, then our triangles are congruent. Reflexive property. Angles, line segments, or geometric figures are congruent to themselves. AC is going to be equal to AC. It is the same line. Segment addition postulate. And I'm going to change this up. We're going to say that this is side C here. Okay. So, whoops. So what the segment addition postulate says is that if we have a line segment AC and some third point B that cuts it, then that means that AB plus BC is equal to the length of AC, okay? So basically we can cut it at any point, but if we add up the two parts, it's going to be equal to the whole. Substitution property of equality. I've talked about this one in the past a few times. First, let's just make sure we understand what a coefficient is before we go into explaining it. Coefficient is the number in front of a variable. So 3 here is my coefficient in my equation. Now, when we're using the substitution property of equality, it's basically letting me replace anything that is equal with something else. Let's explain that. So we have the equation 3x minus 7 equals 2x minus 1. And we've done all of this work here to show that x is equal to 6. The substitution property of equality lets me replace x, because x and 6 are equal to each other. Because they're equal to each other, I can replace here my x with a 6. Okay, and remember that 3x is 3 times x, so we're doing 3 times 6 to solve. Congruence and transitive property of congruence. Okay, so definition of congruence means that two figures are the same shape or the same measure if and only if they're congruent. So if we have two figures that we're showing, angles are same shape, same size, then they're congruent. If something is congruent, that means their same shape and their same size is also equal. And that is this if and only if. We can work whatever direction we want to when we're working with the definition of congruence. We can start with congruent and therefore something happens, or we're showing that something is equal, same shape, same size, therefore they're congruent. Now, transitive property of congruence. The property states that if two shapes are congruent to the third shape, then all the shapes are congruent. So basically what it is saying is if we have triangle A and it's equal to triangle B, and we have triangle B and it's equal to triangle C, then that means that triangle A is equal to triangle C, okay? So if two shapes are congruent to the third shape, so both of these two shapes, A and C, are equal to B, then all the shapes are equal. So in that case, I kind of have a picture here where we have triangle A and we have triangle C, and we're saying that both of them are equal to this triangle B. That means that A and C are also equal to each other. Division property of equality. This basically just states that when we divide two things by the exact same value, that it produces then what we have created is equal. So we have our equation here, 2x and 6. We divide both of them by 2, both sides of the equal sign we divide by 2. That means that my answer x equals 3 is also equal to each other. We're doing the same thing on both sides. Okay, that is it for this lesson, this vocabulary lesson. Up next, we will talk about rectangles and the proofs associated with them. Like always, please reach out if you have any questions, and until next time.